In mathematics, a percentage, from Latin percentum, by 100, is a number or ratio expressed as a fraction of 100. It is often denoted using the percent sign. For example, 45% is equal to the fraction 45 over 100, the ratio 45, 55, or 45, 100, when comparing to the total rather than the other portion, or 0.45. Percentages are often used to express a proportionate part of a total. Example 1. If 50% of the total number of students in the class are male, that means that 50 out of every 100 students are male. If there are 500 students, then 250 of them are male. Example 2. An increase of 15 cents on a price of $2.50 is an increase by a fraction of 0.15 divided by 2.50 is equal to 0.06. Expressed as a percentage, this is a 6% increase. While many percentage values are between 0 and 100, there is no mathematical restriction and percentages may take on other values. For example, it is common to refer to 111% or negative 35%, especially for percent changes and comparisons. History. In ancient Rome, long before the existence of the decimal system, computations were often made in fractions in the multiples of 100. For example, Augustus levied a tax of 100 on goods sold at auction known as centesima rerum venalium. Computation with these fractions was equivalent to computing percentages. As denominations of money grew in the Middle Ages, computations with a denominator of 100 became increasingly standard, such that from the late 15th century to the early 16th century, it became common for arithmetic texts to include such computations. Many of these texts applied these methods to profit and loss, interest rates, and the rule of 3. By the 17th century, it was standard to quote interest rates in hundredths. Calculations. The percent value is computed by multiplying the numeric value of the ratio by 100. For example, to find 50 apples as a percentage of 1,250 apples, one first computes the ratio 50 divided by 1,250 is equal to 0.04, and then multiply by 100 to obtain 4%. The percent value can also be found by multiplying first instead of later, so in this example, the 50 would be multiplied by 100 to give 5,000, and this result would be divided by 1,250 to give 4%. To calculate a percentage of a percentage, convert both percentages to fractions of 100, or to decimals, and multiply them. For example, 50% of 40% is 50 100 times 40 100 equals 20 100, or 0.50 times 0.40 is equal to 0.20 times 100 equals 20%. It is not correct to divide by 100 and use the percent sign at the same time, it would literally imply division by 10,000. For example, 25% equals 25 divided by 100 is equal to 0.25, not 25% divided by 100, which actually is 0.0025. A term such as 100% per 100% would also be incorrect, since it would read as 1% even if the intent was to say 100%. Whenever communicating about a percentage, it is important to specify what it is relative to, i.e., what is the total that corresponds to 100%. The following problem illustrates this point. In a certain college, 60% of all students are female, and 10% of all students are computer science majors. If 5% of female students are computer science majors, what percentage of computer science majors are female? We are asked to compute the ratio of female computer science majors to all computer science majors. We know that 60% of all students are female, and among these 5% are computer science majors, so we conclude that 60, 100 times 5, 100 equals 3, 100, or 3% of all students are female computer science majors. Dividing this by the 10% of all students that are computer science majors, we arrive at the answer, 3% per 10% equals 30, 100, or 30% of all computer science majors are female. To find percentages of more than 100%, divide the percentage by 100, and then multiply it by the number which you want to find the percentage of. Due to inconsistent usage, it is not always clear from the context what a percentage is relative to. When speaking of a 10% rise or a 10% fall in a quantity, the usual interpretation is that this is relative to the initial value of that quantity. For example, if an item is initially priced at $200 and the price rises 10%, an increase of $20, the new price will be $220. Note that this final price is 110% of the initial price. Some other examples of percent changes. An increase of 100% in a quantity means that the final amount is 200% of the initial amount. 100% of initial plus 100% of increase equals 200% of initial. In other words, the quantity has doubled. An increase of 800% means the final amount is 9 times the original. 100% plus 800% equals 900% equals 9 times as large. A decrease of 60% means the final amount is 40% of the original. 100% minus 60% equals 40%. A decrease of 100% means the final amount is 0. 100% minus 100% equals 0%. In general, a change of X% in a quantity results in a final amount that is 100 plus X% of the original amount. Equivalently, 1 plus 0.01X times the original amount. Percent changes applied sequentially do not add up in the usual way. For example, if the 10% increase in price considered earlier, on the $200 item, raising its price to $220 is followed by a 10% decrease in the price, a decrease of $22, then the final price will be $198, not the original price of $200. The reason for this apparent discrepancy is that the 2% changes, 10% increase and 10% decrease are measured relative to different quantities, $200 and $220 respectively, and thus do not cancel out.